question or you can't do the question. If you can do the question, you can do it quickly. If you can't do the question, you're just sitting there. So, watch. I know, but physics, you don't really. It's either you can know how to do it or you don't know how to do it.
Because if not, you can do it right away.
Yeah, that's my point. With the physics, you should look at it and go, right, I know what to do. With the maths, I understand you might need to think about it, you might try some different things, but with the physics, it should be just more of a case that, alright, I know this type of problem, I'm doing it. Like, watch. So, here, what's the difference between a scalar and a vector?
Scalar contains only magnitude, but vector quantity has magnitude and the direction.
Scalar has only magnitude, vector has both magnitude and direction. Examples, speed, scalar. Velocity, vector. No. So that's part A done. Part B. Can you just read part B out to me, please?
A man attempts to swim directly across a river.
Yeah.
Of width to 15 meters.
Yeah.
The man swims at a speed of 1.4 meters per second.
Yeah.
Relative to the water.
Yeah.
But the river flows in a direction perpendicular to the river bank.
Yeah.
The speed of 5.6 meters per second. Relative to the bank.
Yeah.
First question is determine the resultant velocity of the man
Yeah.
with respect to the bank.
I think there was a typo in that question. I believe they meant to say parallel to the bank, not perpendicular to the bank.
Oh, really?
Yeah, well, I mean, this is how you drew it.
Yes, exactly.
Yeah. So this is right, the way it is on the board. So the man can swim at 1.4, but the river carries him at 5.6. So in total, he doesn't swim straight across. What will happen to him? He'll end up going this kind of diagonal way.
Yeah.
He tries to swim straight, but the river carries him down. How can we get the magnitude? Pythagoras. Correct? So from Pythagoras, this here is 5.77. And how can we get the angle?
By using the
Tan inverse. Tan inverse Tan inverse 1.4 over 5.6. 14 degrees to the bank. Down stream. To the bank. Is that it for B? How far has the man travelled when he's moved down the river before he reaches the other bank? Okay, so in other words, how far does he travel? Well, think about this. Vertically, yes?
Before this, because we can just say like to do this, we have to say let's do it for 1 second. Then we can take a speed as the...
Yeah, you could do it like that, that's fine. The way I was thinking about it was like this, look. He travels vertically at 1.4 meters per second, true?
Yeah.
Vertically, how far does he have to travel? 15. Distance, speed, time means he will be traveling for 15 over 1.4 seconds. So how long will he be traveling for? 10.7 seconds. Now, how fast is he traveling diagonally? 5.77. So distance equals speed multiplied by time. So that will be 10.7 multiplied by 5.77. So that will equal, he has travelled 61.8 meters. That's the...
That's so cool, 61.
How long does it take him to travel the vertical distance of 15 meters? We are agreed it's 10 seconds?
Yeah.
And how fast does he travel diagonally down?
1.4.
No, 5.77 diagonally.
Oh, yeah.
This is his actual movement, not his vertical movement. It's like projectiles. You look at the listen carefully. Look at me so I can at least imagine you're listening to me. This is like projectiles. You use the vertical part to get the time. Then once we have the time, we go back to looking at his actual diagonal movement. He's doing 5.77 meters per second at an angle of 14. So he'll end up travelling that Now look, there's another way to do it as well. You could work out how far he travels horizontally. It'll be 5.6 multiplied by 10.7. And then if you know it's horizontal and vertical, you can get the diagonal. It'll be the same. Okay. Now that's the B part. Can we have a look at the C part? Right, so a ball is thrown, angle 40, height, okay. So C. What height is the ball thrown at? No.
Height 9.25.
Okay, so it's not really a person holding it then.
It's a building, I think.
Okay. So this here is 9.35. And what's the angle? 40. And what's the speed? 18.6. So how do we get the horizontal part? 18.6 cos 40. This is 14.25 meters per second. 18.6 sine 40. This is 11.96 meters per second. First question is, what is the maximum height?
How did you get 14.25?
Huh?
14.25.
Yes. Cos 40 times 18.6. Dude.
Was in radian or?
Ah, what a classic KJ mistake.
What is that answer?
No, I haven't done it yet.
Okay.
The first answer is what's the maximum height. So we should look at the vertical component. Vertically, UVATS. What's the U vertically? 11.96. What's the V vertically at the top? 0. A?
Minus 9.1.
Yeah. So we are looking for what?
9.
The S.
Oh, yeah.
What formula could I use to get the S? B squared equals U squared plus 2AS. V squared equals U squared plus 2AS. S equals 7.29. But that's not the right answer. The answer is 7.29 plus 9.35. Why do I add the 9.35? Yeah, because we should measure it from the ground level, not from the origin. Right, part 2. What do I want in part 2? 16.64, the final answer.
What is that for 7.29?
Yeah. No? It is correct, Fahad. Right, the second part, what do I want in part 2?
One thing. Sine, cos.
Time.
Right?
Yeah?
And then you just say cos, right?
No. Help me. What?
My answer is cos.
Did you type in 18.6 cos 40 to get the horizontal? But I'm not using that, I'm using the vertical.
Sine, yeah, use sine.
Right, so look, 18.6 sine 40.
No, I'm just thinking.
Alright, fine, I'm continuing.
Yeah, okay.
Right, what do I want next? The time. So, what formula should I use here? V equals U plus a T, so the T equals 1.22 seconds. Right, what do I want next? The time taken for the ball to reach the ground. So again, do I look at horizontal or vertical? Horizontal or vertical? Vertical. Yeah, vertical. 11.96. V we don't know. A is minus 9.81. T we don't know. And what's S? 'Tis not. Minus 9.35. Yeah. So I'll use my formula. S equals U T plus a half A T squared.
So the minus 9.35.
It's 9.35 meters below where it started. The time here is 3.06. Here is ground level.
Okay.
What is this height here? 30 centimeters.
And plus the 9 points.
No.
Height.
No. Here is ground level.
Okay.
Here its height is 10 centimeters.
Okay.
Here its height is minus 10.
Okay.
So the S is minus 9.35. Because it's 9 meters below where it started. And it started here.
What do you got for time?
And it ends here. At this 9 meters below, 9.35 below
We're
where it started.
supposed to use the height of the...
No.
What do you got for time?
Because remember, S is displacement, KJ, not distance. No, I need some kind of acknowledgement that you got that or not. Now, in serious? Continue. Now, what type of equation is this here? Quadratic, so that's easy. I rejected the negative answer. Right, next. How far does it travel when it hits the ground? Horizontally. So if I look at the horizontal part now, UVATS, what's the U horizontally?
Did you add the time?
Add the time to what?
The whole time.
No, I didn't. It's just 3.06, trust me. We don't add the time to the max height.
What is the maximum?
Okay.
Sorry, what is it, KJ?
14.25.
And is it accelerating horizontally? No, the T 3.06. S equals UT. And finally,
Excuse me.
yeah.
Third one is total time.
Yes, total time from the beginning to the end. I didn't break this up into two problems. I didn't go time from middle to top and top to end. My 3.06 is from the beginning to the end. I did not use the maximum height or the time to max height at all. You see, you and I do these two different ways.
Yeah.
You work out the time to max height and then max height to ground. I don't. I just do time from start to ground.
Well,
What
will
is
you
the
get,
answer
are you
for
supposed to
second?
get C also?
As what?
Like,
Yes.
What was your answer for the second part? C2. 1.22?
Yeah.
Got it.
Okay, great. Well, I'm delighted. Okay, so lastly, what is the kinetic energy when the ball hits the ground?
half MC squared.
Yeah, but the kinetic energy, wait! It should equal the potential energy at the start,
Yes.
which is a much easier calculation because it's just mgh. What's the m? 0.45, the g 9.81, and the height from the ground?
5.2.
Can you multiply those three numbers? Of course you can, you're physics students. 0.45 times 9.81 times 9.35. The kinetic energy at the end is 41.3 joules. Is that right? No, I made a mistake actually. Because I forgot, it doesn't have only potential at the start, it also has kinetic at the start, doesn't it? So I should have said kinetic at the end is potential and kinetic at the start. So it's still my previous answer. What did I just say a minute ago for MGH?
41.3.
Yeah, so it's still 41.23, but now I must add in the starting velocity, a kinetic energy. What's the starting speed? 18.6. Okay, now I just have to add that piece in here. Plus a half mv squared. So total is now 119 joules. This is at the start. It is not. This is at the end. This is at the start. The kinetic energy at the end is equal to the potential and the kinetic at the start. Right, 119 joules. So this question took me 15 minutes to do. You have up to half an hour to do it in the exam.
Did you go back on the geometry?
No, I need to go home, but I'm going to upload this when I get back to the teacher's room.
Okay.
I didn't give you a break. You were still working when I went to the bathroom. Weren't you?
Weren't you?
Weren't you? Yeah, weren't you?